Okay, suppose that now next problem. Suppose that our day's production of 850 manufactured parts contains 50 parts that do not conform to customers' requirement. Okay, so N is equal to 850 parts. Out of 850, 50 parts that are not conform means damaged to customer requirement. Two parts are selected at random without replacement from the batch. Let the random variable x equal the number of non-conforming parts in the sample. Okay, so non-conforming parts in the sample. Now total number of samples is 2. So no no damage, no bad product, one bad product or two bad product. Identify probability mass function, probability distribution and distribution function. Okay, so total number of data 850. So out of 850, 50 are damaged. Okay, now we are taking two sample. So from the two sample, one may be the two are good, two may be the good, so 0 bad. One may be the good, another may be the bad. One may be the good, another may be the bad. One problem, both are bad. Okay, now if probability of x is equal to 0 means no bad product is there, so total, so out of 850, 50 are bad, so total good items 850 minus 50, it is 800 good products. Okay, so probability of getting first good product equal 800 by 850, total number of favorable event by total number of event. So first good product. Okay, so for this one first good product. Now second time one less, so 799 because it is without replacement. 799 by 849, one less. Clear? So the answer is 0.886. Similarly, if x is equal to 1, so one bad product, one good product, this case one good product, one bad product. Now so in this case good product, probability of good product getting good product. Now total 50 bad products are there, so 50 by 849 plus first first one is a bad product, so 850 into 800 by 849. Okay, so good product, bad product, bad product, good product. Okay, so the answer is 0.111. so if both are bad, not conforming, so 50 by 850 into 49 by 849, the answer is 0.003. Okay, so this is nothing but our probability mass function. Now second, probability distribution. So it's order pair, so 0, 0.886, 1, 0.111, 2, 0.003. So this is nothing but our probability distribution. Next, distribution function. So for distribution function, f0, that will be nothing but probability of capital X less than equal to 0, that is 0.886. okay, 0.886. now f1, that is probability of x less than equal to 1, so addition of these two, so addition of these two is 0.886 plus 0.111, that is 0.997. and finally f2, probability of x less than equal to 2, that is addition of this and this, so 0.997 plus 0.003, so that is 1. Okay, so probability mass function, probability distribution, and distribution function. Next problem. Problem related to discrete random variable. Determine the probability mass function of x from the following cumulative distribution function. Okay, so distribution function is there given. 0 if x less than equal to 2 minus 2, 0.2 if it is minus 2 to 0, 0.7 if it is this one, and 1 if x is more than 2. Okay, so identify probability mass function, and probability distribution. And obviously distribution function is also we can identify. Now we can see here solution. Now we can see here the random variable will be somewhere like that. So 2, okay, so it may be 2, it may be 0, okay, it may be minus 2. So minus 2, 0 and 2. So random variable will be 2, 0, minus 2. Now already we know the formula, if b minus if a is equal to probability of x and b. Clear? So if you write, so from this particular we can from this particular given data we can identify this way. If minus 2 is equal to 0.2, okay, if it is 0 minus 2 it is 0.2. Clear? So it is not, x is not 0 but x is equal to minus 2. If is equal to 0 then it is 0.7. If x is equal to 0 then it is 0.7 because x is less than 2. Now f2 it is 1. So this is nothing but our distribution function. Okay, so this is nothing but our distribution function, okay, or cumulative distribution function. Now we have to identify the probability mass function. So p 0, okay, x to 2, that should be what? f2 minus f0. So what is f2? f2 is 1. What is my 0? 0 is 0.7. So that is 0.3. Okay, so probability of x equal to 2 will be 0.3. Okay, similarly probability of minus 2 x less than equal to 0 is equal to f0 minus f minus 2. Clear? So f0 is what? 0.7, f minus 2 is 0.2. It is 0.5. So probability of x is equal to 0 is equal to 0.5. And finally p x is equal to minus 2 will be 0.2, the first one. Okay, because it's a cumulative one, so first will be the same as this one. So first one, this one, second addition of these two, so 0.5 plus 0.27, it is the second one, and the third one. Clear? So probability x is equal to 2 is equal to 0.3, x is equal to 0 is equal to 0.5, probability of x is equal to minus 2 is equal to 0.2. So this is nothing but our probability mass function. And probability distribution is very simple. It's an order pair. So 2 comma 0 0.3, 0 comma 0 0.5 minus 2 comma 0 0.2. So this is nothing but our probability distribution, probability mass function, cumulative distribution function. Okay. Now we solve related to continuous random variable. Let the continuous random variable x denote the current measured in a thin copper wire in a milliampere. Okay, in a milliampere. Assume that the range of x is 0 to 20 milliampere, and assume that probability density function of x is probability density function x is 0.05. Okay, so fx is 0.05 if x is in between 0 to 20, 0 otherwise. Okay, so what is the probability that current measure is less than 10 milliampere? First question. And second question, what is the probability that current measure is in between 5 to 20? So first of all, to solve this particular problem, draw the figure. So it is from 0 to 20, it is fixed. It is this one, 0.05 to this particular area. Okay. Now, first question is, what is the probability that current measure is less than 10 milliampere? So current measure is less than 10 milliampere. So that means we have to identify 0 to 10, 0.05 dx. Okay, so 0 to 10 means say somewhere here. So we have to identify this one, this particular area. Okay, that is a integration 0 to 10 because lower limit is 0 and our upper limit is 10 here, so it is 10. So if you solve it, we can get the value 0.05 x 0 to 10. Okay, so 0.05 into 10, that is 0.5. So the probability is 0.5. And first question. Second question, what is the probability that current measure it in between 5 to 20 milliampere? So we have to identify 5 to 20 milliampere. Okay, so 5 to 20, 0.05 dx. Okay, so 0.05 x 5 to 20, so 0.05 into 20 minus 5, integration formula into 15. Okay, 0.75 is the answer. Okay, if cumulative distribution function is there, how to get the probability density function? Here, the cumulative density function of a continuous random variable x is fx, which is nothing but property of x, which is less than or equal to small x, minus infinity to x, ft dt for x less than equal to x, less than x, less than x in between minus infinity to plus infinity. The probability density function of a continuous random variable can be determined from the cumulative distribution function by differentiating. That means d by dx minus infinity to x ft dt is equal to fx. Okay, so for the given, if fx is given, then if fx is given, then fx, small fx is dfx by dx, as long as the derivative exists. Okay, now just solve one problem. The time until a chemical reaction is complete in millisecond is approximated by the cumulative distribution function. Cumulative distribution function 0 if x is less than equal to 0, 1 minus e to the power minus 0.01 x. X should be less than x. 0 should be less than equal to x. Now determine the probability density function of x, and what is the probability that reaction will complete within 200 milliseconds. Okay, so solution, the how to calculate the probability density function. So we have to apply dy dx for this particular, on this particular data. Okay, so fx is equal to d by dx 1 minus e to the power minus 0.01 x dx. Okay, and its answer is 0.01 e to the power minus 0.01 x. Okay, that means probability density function 0 if x less than 0, and if less than equal to, if x is more than equal to 0, it is 0.01 e to the power minus 0.01 x. Okay, so it is nothing but our probability density function. Next question, what is the probability that reaction will complete within 200 milliseconds? Okay, so that means x less than equal to 200 milliseconds. Okay, so that means if 0 to 200 milliseconds, 0.01 e to the power minus 0.01 given. Okay, capital second cumulative density function is given. So fx is equal to 0 if it is less than 0, x is less than 0, 0.3x if it is x in between 0 to 5, and 1 if x is more than 5. Okay, so dy dx 0.3x, it is nothing but 0.3. Okay, so probability mass function, sorry, probability density function is 0 if less than x. Okay, and 0.3 if it is x to 8. Second, x greater than 6. Third, x less than equal to minus 1. And fourth, x should be in between 1 to 3. Okay, so to calculate, so already know to fx is nothing but dfx by dx. Okay, we have seen. Now d 0.3x by dx, so 0.3. Okay, so that means fx is equal to, if 0.3 if x is less than x, sorry, it is 0 if 0 is less than x, x is less than 0, 0.3 if x is in between 0 to 5. Okay, it is in between 0 to 5. So we can draw a figure for that. So if you draw a figure, so 0 to 5, it is 0.3. Okay, it is 0.3. Now first is what? Less than 2.8. Less than 2.8 means 2.8 means we have to identify this particular area. So that means 0 to 2.8, 0.3 dx. Okay, so 0.3 into 2.8, so it is 0.84. Okay, answer is 0.84. Next, what is about if x is greater than 6? So greater than 6 always it is 0. Okay, it is 0. So or less than 6 means we have to identify this particular area. So answer is 0, but we can show like this way, say 6 to infinite 0.3 dx, or 1 minus 0 to 6 0.3 dx. 1 minus the whole value is 1, so 1 minus 1 0. Okay, next less than minus 1, so minus 1 will be somewhere here. Okay, so obviously it is was 0 in between 1 to 3. So in between 1 to 3, 1 to 3, we have to identify this particular area. So that means 1 to 3 0.3 dx. So 0.3 c constant 1 3, so 0.3 into 3 minus 0.3 into 1, so 0.9 minus 0.3 0.6. Okay, and that is the end of this particular video. Thank you very much.